Hello, hi everyone. Welcome to the Student Brand. This is Evasvase. Today topic is motion in a plane. Motion in a plane. Okay, so if the object is moving with respect, so if you want to describe the position of the object, so if it is necessary by using two axes, those are x-axis and y-axis, then we can say body is moving two-dimensional motion. Example, circular motion is the best example. Okay, so now, so we are talking about motion in a plane, that too projectile motion. So I will explain about projectile motion. Projectile motion, okay, projectile motion. If the particle, if the object is thrown, so if the object or particle, okay, so very good. Good job. I hope you wrote well. Chandrakant, nice. Okay. Now, so you can see here, when you throw the particle, when you throw the object, okay, when you throw the object, okay, so it is making angle theta with respect to x-axis, with respect to x-axis. So here you can observe this is x-axis and this is the y-axis, y-axis. Okay. So if the object is thrown with certain angle with the x-axis, or we can take the ground. So like that, if you are throwing the object, yes or no? If you are projecting the particle, if you are projecting the particle, if you throw the object, okay. So now here, this is along x-axis. So with velocity u. So the object is thrown with a velocity u. Initial velocity. Okay, initial velocity u, right? So if you resolve the component, so I already explained scalars and vectors. Scalars and vectors, in that I explained clearly about resolving the vector. Resolving a vector, okay, along x-axis and along y-axis. Along x-axis and along y-axis. So velocity is a vector, right? Velocity is a vector quantity. If you resolve the component, if you resolve the vector into two components along x-axis and along y-axis, along x-axis and along y-axis, right? So here we have to resolve. So along x-axis, ux equal to u cos theta, and along y-axis, uy equal to u sin theta. Uy equal to u sin theta. I hope it is very clear. Once again. So ux equal to u cos theta, uy equal to u sin theta. U sin theta. Yes or no? So I will resolve and show. Later you can see. So if you are taking like this, okay, so this the velocity u. So on x-axis, so this is the x and y, this is theta. Then cos theta equal to, what is the cos theta formula? Adjacent side by hypotenuse, x by u. So x equal to u cos theta. Okay. And coming to y, so sin theta equal to y by u, then y equal to u sin theta. U sin theta. I hope it is very clear. So like that we can take along x-axis, so x equal to u cos theta, along y-axis y equal to u sin theta. Y equal to u sin theta. Is it clear? Right. So next, so like that, along x-axis u cos theta, along y-axis u sin theta. So I'm taking, right? Now, now you can see, now you can see. So it is a particle at time t. At time t, so u cos theta and u sin theta. So this is the maximum height. This is the maximum height. Okay, so at this point, so horizontal velocity is there only u cos theta. throughout the path, horizontal velocity is constant. Horizontal component of velocity. So that is u cos theta. U cos theta. Horizontal component of velocity. U cos theta is constant. Okay, at maximum height, so velocity becomes zero. So we can take Vy equal to 0. So this is a maximum. Anyway, Vux equal to u cos theta only. Because throughout the path, u cos theta is not changing. U cos theta is constant. So then we can take Ax equal to 0. Then Ay equal to minus G. Right? So these quantities are very, very important. And Uy equal to u sin theta. Uy equal to u sin theta. U sin theta. And Vy equal to 0. Vy at maximum height. At here, Vy equal to 0. So at maximum height. At maximum, maximum, at a maximum height. Understood? So I hope it is very clear. So these are the points. Once again, ux bx equal to u cos theta. If horizontal, along horizontal, so u cos theta is constant, then automatically along the horizontal direction, ax equal to 0. Along horizontal direction, acceleration is 0 because constant velocity is there. If constant velocity, final velocity minus initial velocity. Final velocity is u cos theta. Initial velocity is also u cos theta. Then change in velocity is 0, right? Final minus initial u cos theta minus u cos theta is 0. So acceleration along x-axis 0. And acceleration along y-axis ay equal to g. That is nothing minus g. Okay. So here you need to understand, you have to think about two directions, along horizontal direction, along vertical direction. So we know equations of motion. Okay, so I'll write equations of motion along x-axis and along y-axis, how we have to take. So after that, we'll go to the remaining point. So we know the formula v equal to u plus at. Okay, so v square minus u square equal to 2as, and s equal to ut plus half at square. S equal to ut plus half at square. So along horizontal direction, horizontal component, along horizontal direction or along x-axis, horizontal. So if you are taking horizontal direction, horizontal direction, okay, along horizontal direction if you are taking, so Vx equal to Ux plus Ax into T. Anyway, time T, so time is same only. Okay, so any direction either along x-axis, along y-axis, T only, no changes. T is T only. Okay, these points are very, very important. Okay, these points are very, very important. Now you can see, so Vx whole square minus Ux whole square equal to 2Ax. So we can take along x-axis, the distance you can take x. So then x equal to Uxt plus half into Axt square. So along horizontal direction, coming to along vertical direction, like we can say this is x-axis, along x-axis, and a vertical direction. So like along y-axis we can say, along y-axis, I hope it is very clear. Along y-axis you can take, along y-axis, vertical direction, that is nothing but along y-axis, along y-axis, along y-axis, along y-axis. So same we are writing, that is, now you can see Vy equal to Uy plus Ay into T, then Vy whole square minus Uy whole square equal to 2 into Ay into y. So along y-axis, right? And so y equal to uy, so t plus half into ay t square. Okay, along y-axis and along x-axis, along y-axis and along x-axis. So these are the equations. How you are writing equations of motion along x-axis and along y-axis. You can observe once. You can observe once. Okay, so I hope it is very clear. I hope it is very clear. Now you can see now. So like this, you have to imagine, right? You have to think about equation of motion along x-axis and along y-axis. You have to consider. Later, so after this, so these points you have to keep in mind. These points while you're doing, these points you have to keep in mind. Now you can observe. Now you can observe. So we know S equal to ut plus half at square. Okay, so this equation we are considering. So to show that path of the projectile or trajectory of a particle is a parabola. Trajectory of a particle means the path of the particle is a parabola. So we are proving path of the projectile is a parabola. Or simply we can say, so in which direction the particle is traveling, that path, so you should prove that path is a parabola. So generally you can see when you are throwing the particle from one position to another position, it moves in a parabolic path. Parabolic path. Now you can see here. So S equal to ut plus half at square. S equal to ut plus half at square. So along x-axis you are taking x equal to uxt plus half into ax into t square. Now you can substitute this. Okay. So these values here. Now anyway x equal to ux equal to u cos theta into t plus half into x equal to 0 because constant velocity, right? U cos theta. Throughout the path u cos theta is same. So that's why acceleration along x-axis 0. Acceleration along y-axis ay equal to minus g. Ay equal to minus g. So now you can take x equal to u cos theta into t, then t equal to x by u cos theta. Okay, so keep in mind this is the equation 1. Now same equation, so you are taking y equal to uyt plus of ay into t square. Now you can substitute y values, y equal to, so uy equal to what? Uy equal to u sin theta. U sin theta, okay, into t. So keep it like this. So plus half into ay equal to minus g. So t square, right? So now you can take substitute t value. Substitute t value in this equation. Substitute t value in this equation. So one in equation 2. So I am taking this equation. Okay, substitute equation 1 in the above equation, or you can give equation 2, the above equation 2. Okay, substitute, right? So y equal to u sin theta into t equal to what? X by u cos theta, right? So plus half into minus g, then x by u cos theta whole square. U cos theta whole square. Right now you can see y equal to here. So you can cancel u here. So sin theta by cos theta is tan theta. So tan theta into x minus of, so g x square by u square cos square theta. U square cos square theta. So y equal to tan theta into x minus g x square by 2u square cos square theta. So this is in the form of y equal to ax plus bx square. Y equal to ax plus bx square. So the equation what you got, that is in the form of parabolic equation. Then the trajectory of a projectile is a parabola, or the path of the projectile is a parabolic. So I hope it is very clear. Understood? Right? So like this we can take. Now, so we'll solve time of flight, maximum height and horizontal range. Okay. So now we will discuss about now. So we'll discuss about time of flight, maximum height and horizontal range. Time of flight. So what is time of flight? Time of flight. Okay, so I have to keep like this, all the points. So now we'll discuss about time of flight. Time of flight. Okay, time of flight. So time taken by the particle to fly in air. So that is the time of flight. Time of flight. I hope it is very clear. Time taken by the particle to fly in air. Okay. So from here, point of projection to point of striking. So from A to B also we can take. From A to B, that is called time of flight. So this is A and this is B. And OA also, OB also we can take anything. Okay, now we can take. So S equal to UT plus half AT square. Right? So the particle is moving upward direction, right? So y equal to, so because, so the particle is traveling, so if you throw from here again it is reaching to the ground. Again it is reaching to the ground. So then displacement is zero, right? Along y direction. So along x direction it will be there, but along y direction it is zero. So 0 equal to uy equal to u sin theta. Uy equal to, or better I'll write, say along, okay, in the format of, so y uyt plus half into ay t square. So now you can see along y-axis, the particle is starting from one point, again reach to the same point. Then along vertical direction, the displacement is zero. Uy equal to u sin theta. U sin theta into t. Okay, so u sin theta into t plus half into minus g t square. Yes or no? So then half g t square equal to u sin theta into t. U sin theta into t. So shall we cancel here? So 1t here you are cancelling now. So t equal to, so that is nothing but time of flight. So u sin theta by u sine, so here 2u sine theta by g. This is the time of flight formula. So time of flight equal to, so 2u sine theta by g. Is it clear? Just check once. Time of flight equal to 2u sine theta by g. Understood or not? So you have to think clearly in which direction you are taking, what are the quantities you are substituting, and okay, so all the values, what are you are substituting, so you should be careful, right, while substituting. So now we can see time of flight equal to 2u sine theta by g. So I'm writing here t equal to 2u sine theta by g. So this is the equation one. So like you can keep it aside. So then maximum height. So now you have to think about maximum height. Maximum height. Maximum height. Right? Maximum height. Maximum height. Okay, so the particle is reached the, so this is the maximum height. So this is the maximum height. Okay, so in the maximum range from here to here is the maximum range. This is the maximum range. From A to B is horizontal wise, that is the maximum range. Vertical is, that is the maximum height. Maximum height. Understood or not? So now we can take the equation v square minus u square equal to 2as. Here vy whole square minus uy whole square 2a. Yes, so here a equal to minus g, s equal to h, and by equal to 0, uy equal to u sine theta. So initially it will be there. When it is reaching to the maximum height, final velocity is 0. And s equal to h, a equal to minus g. Substitute the values. Now you will get 0 minus u sine theta whole square. So 2 into minus g and capital H. Now you can observe minus u square sine square theta equal to minus 2gh. So both minus will get cancelled, then it will become plus. Then final formula. So maximum height we are asking. So maximum height equal to u square sine square theta by 2g. So this is the maximum height formula. Maximum height. So right here. H equal to u square sine square theta by 2g. U square sine square theta by 2g. I hope it is very clear. Yes or no? Now we will discuss about horizontal range. Horizontal range. Okay. So horizontal range. Horizontal range. Horizontal range. Horizontal range. So range you can say. So range. Okay. Maximum range. So this is the maximum range. So when it will be? According to the angle theta. Okay. So this is the height, maximum height here. So when theta, if you substitute accordingly, you'll get it. So now I'm substituting one more. So S equal to UT plus half AT square. This time you are taking along horizontal direction, right? Along horizontal direction. That's why x equal to UXT plus half AXT square. Now AX anyway 0, right? This time along a horizontal direction. Along a horizontal direction. Along a horizontal direction. So here you have to substitute the values. ux equal to u cos theta and ax becomes 0 and here maximum time of flight. Okay, from here to here it traveled, right? So range. So now, so time of flight is 2u sine theta by g. 2u sine theta by g. Okay, auto substitute here. So x equal to x is nothing but range r. Okay, how to substitute in the place of x, you have to substitute r, right? So substitute all the values. Now r equal to u cos theta into t plus anyway this total term becomes 0. R equal to u cos theta into t equal to 2u sin theta by g. 2u sin theta by g. Now r equal to, so you can take common 2 sin theta cos theta by g. So 2 sin theta cos theta is nothing but sin 2 theta. So u sin 2 theta by g. So actually here u is there, u square. Yes or no? Here u is there, here also u is there, u square. U square sin 2 theta by g. This is the range. Okay, so range r equal to, so u square sin 2 theta by g. Okay, so I hope it is very clear. Just check once. Just check once. So these are all formulas to range. So r equal to u square sin 2 theta by g, h equal to u square sin square theta by 2g, time of flight t equal to u sin theta by g. So I hope it is very clear, right? So check once. Check once. This is about projectile motion. This is about projectile motion. Okay. So now, so I hope it is very clear, right? T equal to 2u sin theta by g, h equal to u square sin 2 sin square theta by 2g, r equal to u square sin 2 theta by g. Right? Yes. Now, so these are the formula range. So when theta, if you substitute 45, when you substitute 45, you'll get maximum height and maximum range. So one check, you'll get it. So now you can see the circular motion. Circular motion. So how the linear quantity will change? So in angular quantities. Okay, so we'll discuss now. When the body is moving in a curved path, then it is called circular motion. When the object is moving in a curved path, then it is called circular motion. So here, now we know v equation motion, v equal to u plus at and s equal to ut plus half at square and v square minus u square equal to 2as. Okay, so those quantities, so we have to convert into angular quantities. So in circular motion, so we are writing theta equal to s and so actually v equal to omega final and I am taking omega 2 and u equal to omega 1. So velocity and coming to acceleration a equal to alpha. Okay, so anyway t is same only. So which are the quantities, what are the system? So t always same. T always same. So those quantities we are writing in the form of angular quantities. Okay, so you can see here. You can see now. So omega 2 equal to first equation, omega 2 equal to omega 1 plus alpha into t, and theta equal to omega 1 t plus half into alpha t square, and omega 2 whole square, omega 1 whole square equal to 2 alpha theta. 2 alpha theta. So these are the angular quantities. Okay. So these are very, very important. So make sure that you're learning all the points. So time of flight 2u sine theta by g. Maximum height h equal to u square sine square theta by 2z. Okay. And time of horizontal range. Horizontal range. R equal to u square sine 2 theta by g. Okay. So thank you so much for joining and attending and listening my class. Thank you so much for joining and attending and listening my class. If you like the content, if you like the channel, if you like my explanation, please do like, share, and subscribe to Student the Brand. This is your Seva signing off. Thank you.